Hello full stackers. So let's continue the program. I'm going to create a new folder, Go Protobuff demo. So the first thing we are going to do is we are going to create a Protobuff file. So .proto file. In the previous video, I explained the process how it works. So first we have to create a Protobuff file. From the Protobuff file, we have to use the compiler to create a client and a server code. And using that, we would be creating our server and starting the server. And using the client generated code, we would be calling the method, which in turn will be calling the method in the server. This is how the flow is going to be. So the first step is Protobuff. Before going into that, we will see, let's go through the documentation of the Protobuff. I am recording the video 2024 February. So in case you are watching the video sometime later, then please go with the latest documentation. So that if anything has been updated, you can accordingly update in the code. So what it says, so protocol buffers are a language neutral. So they are not dependent on any language. They are the language neutral platform, neutral extensible mechanism for serializing structured data. So they are used to serialize the structured data. It's like JSON except it's smaller and faster. So because it works on HTTP2, so it's going to be faster in the binary transfer of the data. It generates native language binding. You define how you want your data to be structured once, then you can use specially generated source code to easily write and read your structured data. So if you have used web service, WSDL file, you can really correlate this. From the WSDL file, we use Axis or any other library and generate the client code. It's going to be similar to that. So we create a contract or the interface definition language. Proto is an IDL. So we create the protocol buffer definition language. Yeah, IDL, and the code protocol compiler generates to interface. Okay. So what problem do protocol buffers solve? Protocol buffers provide a serialization format for packet of typed structured data that are up to few megabytes in size. The format is suitable for ephemeral network traffic and long-term data storage. Protocol buffers can be extended with new information without invalidating existing data or requiring code to be updated. Protocol buffers are the most commonly used data format at Google. It was actually the gRPC was initially created by Google. The protocol buffer messages are described by engineer author Protobuff. Okay, so let's go into the process of creating a file. So I've created the project. I'll create a folder as common. So inside the common, I'll create a new file and rename this as service.proto. So this is going to be service.proto. When I open it in an editor, then I give this first message person. Okay, it's an object, but I will give request. Okay, request message. This is a syntax. Okay, message is, this is what my message is, and the object name is request message, and optional I am going to pass only one string as request. The same way I'll create another response message and string response. I'll go capital. Okay, so here you can see 1, 2 and 3, right, the numbers. So here they would have given what are the benefits of using compact, fast. It's available in many programming language. So cross program compatibility. Using the Protobuff, you can generate code for any of the below languages: C#, C++, Java, Kotlin, Objective-C, PHP, Python and Ruby. The following languages are supported by Google, but the project source code resides in GitHub. The Proto uses plugins for these language. So for these two, we need the plugins. when are protocol buffers not a good fit? So this definitely we have to understand before using it. So you can go through this. Assume that the entire memory message can be loaded into memory at once and are not larger than an object graph. The assumed data may have different binary serialization. Okay, you can go through this. And who uses? So gRPC, Cloud, Google Cloud and Envoy proxy. So how protocol buffer works? Create a proto file to define the data structure. So we have the proto file and we pass that to the compiler and generate the code using the Proto-C compiler. The Proto-C compiler generates the code in our respective language. The compile PB code with your project code. So we take that file and we compile it. We compile PB code with your project code, output compiled classes to serialize. Yeah. So we use that code in our project code and then we get our classes. So from there, when we hit our classes, the classes internally uses the PB class to serialize the data and deserialize the data. So this is how it works. So here, what I wanted to show. So the fields can be message, the numbers, right? There was, okay, we have Proto 2 and Proto 3. The latest is Proto 3, which we will be using now. So defining a message type. So this is how the proto message looks. Message, the object name and followed by the parameters. We have to go syntax Proto 3, otherwise it's going to take Proto 2. So the first line you are using Proto 3. Then the message and field number. So you can see here the field number must be between 1 to 536870911, between 1 and this number with the following restriction: 19,000, 1900,000, right? 1,90,000. No, 1,09,000 to 1,09,999. They are reserved for the protocol buffer. So we should not use these numbers. So these are used to identify. If you read this documentation, they would have mentioned 1 to 15 will use 1 byte and more than 15 will use up to 2047 will use take 2 bytes. So you can go through this. Okay, so we have created the syntax, we have created the message and this. Now the next step, our Protobuff is ready now. The next step is to generate this code specific to Go, because the current playlist we are using Go language. So we will be generating the classes for Go. I'll go to the reference here. So generated code. So here the protocol buffer compiler requires a plugin to generate the Go code. Install it using Go 1.16 or higher. So if I go to my folder, Go version, I have 1.22, which is latest. So they are asking to install this plugin, which I am going to do. So it is installed, and the next step, this will install Proto-C Gen Go binary. So protocol buffer produces output. So next they have the syntax to generate the code. Here Proto-C, the proto path and go out. These are the command line parameters, the output path and source relay to, and where is our file? Our file is service.file. Program not found or is not executable because it is not available in the bin. So I have to export this in the bin, for which I already had a command. So export path equal to $path colon go env path bin. I'll give this. Now let me try. Unable to determine go import path, or yeah. So that brings us to the next section. For Go, we have to give an import path because Go needs a module, right? So we have to give an import path in the Protobuff. So in the documentation, they would have mentioned in order to generate Go code, the Go package import path must be provided for every proto file. There are two ways: by declaring in the proto, by declaring in the command line invoking proto-c. We recommend declaring in the proto file. So Go package, our package name will be fizz. Okay, I am just retaining the same. Once we have added the option Go package, so if I execute the command, service.pb is generated. We don't have the server side code. Next, we have to add the function. So I am going to add the service, which is again a keyword. The service name is say hello and the function name is hello. And the input would be request message. The response would be return. So this is the method. So this Protobuff, I am defining the interface, the method, its request type, return type, and the definition for the request and the return. Now again, if I go and generate the line, I'm going to get both the client side and the server side code. So this is the next step. Using the Protobuff, we have created the server and the client side code. The next step here would be creating our server application using this generated code and then creating the client application and calling the server from the client side. So we will continue that in the next video.